Welcome to A Word from the Wise, the podcast from Solwise, where we talk about products, news, or anything that you might be interested in within the industry. We do these on Spotify, Amazon Music, or anywhere where you get your podcast from. Or if you prefer to see us, you can scare yourself and go and watch us over on YouTube and enjoy today's podcast. Okay, welcome to A Word from the Wise with the Solwise podcast, and we're joined today with Hugo and John from Poynting. We're going to talk about the high-end marine antennas, mainly I guess probably the Narwhals, the Ripples and the WaveHunters. So firstly, it might be worth you telling us some key features about the differences between those three. What makes a high-end antenna different from the ones that we sell as our everyday antennas? Because I mean, we can all admit, I suppose, we sell fewer of these types of antennas. But if you want to tell us a bit about the differences, then that would be useful information.
No, sure. Probably I'll take that one, Louise, and thank you Solwise for the opportunity to have us here. They are indeed different, and not only the fact that the kind of materials that we use. So there are two base things for two antennas, right? The electrical design and then the mechanical design. And then the electrical design, in a way, we were doing it correctly and there are already very good antennas in our inland portfolio. But then we had to bring a better and improved mechanical design if we're going to install them on maritime applications. So in the electrical part, we keep all the good stuff we were doing already. So a very good balance in all the frequencies that our customers care about. So the 4G, 5G, some Wi-Fi antennas that we have as well, and then the balance between gain, VSWR, radiation pattern, and we will go a bit more about radiation pattern in a bit. But the directionality, so if it's directional or omnidirectional, polarization, and then diversity. Now we have 4G, higher 4G grades and 5G, and that of course comes with MIMO antennas. We will discuss them, I'm sure, as well. But then we do this well, right? Balancing all of this across all the frequencies that the antenna covers. But then we had to look at the mechanicals, meaning the build materials, all the accessories, make sure that these were fit for purpose. So I would say that the reason why they're high-end, or it's the environment where they're installed that demands from us that they are high-end and that they can cater and we endure through those conditions.
I've got a question right at the end, actually, of my list of questions, but it would be useful perhaps to bring it in now. When these, for instance, the WaveHunter and the Ripple, they came in at IP65, and I was quite interested that the other antennas generally for marine have been IP68. Is that because of where they're placed on the ship or something like that, or because you use different types of materials?
It has a few reasons why that is. So I think the first thing is we learned throughout experience and through time and by having talks with the industry that we were probably over-speccing. So we did IP68 and IP69K on all our maritime antennas. But then if we really look at, say, the satellite antennas, and then even if we consider the most recent satellite antenna dishes, like the dishes from Starlink, they aren't IP68. They aren't IP69K. So I think that and the experience that we have and the tests that we conduct in-house and the military specs that we adhere to, they show that IP65 would be sufficient or more than sufficient. Because if we look at what IP65 stands for, it's still protected from total dust ingress and protected from low water pressure jets, so from any direction. So means that if you place your antennas, and indeed you're right, that especially if we're considering the Ripple and the WaveHunter, the positioning on the vessel, probably it's a bit more, protective from being under a big wave. But taking all these past experience and considerations into account, that's why our engineers decided to go for IP65 for the last antennas that we have produced.
Yeah, that's really useful. I was thought it was a bit odd, and so yeah, that explains it. Yeah, thank you very much. Can you explain the importance of antenna gain? Because I that's another one that it's all a bit different, and I was just wondering on these higher end, how does that all factor in?
Yeah, so antenna gain is something that a lot of people talk about and not a lot of people understand. I think we're triggered to think that gain is just a number, right? So we look at the data sheet of a technical sheet of an antenna and we see, okay, it covers these frequencies. And then there's a number saying X dBi, 3 dBi, 6 dBi, 9 dBi, whatever it is. And people are under the assumption that the higher the gain, the further from shore I will keep connected, which in theory could be true, right? You're increasing your capacity to focus energy on that given direction. If we're talking about an omnidirectional antenna, that would be 360 degrees. And then you will, of course, be able to communicate further away. Now, as we were talking about what makes our high-end antennas or our antennas good, it's really this balance between across all those frequencies, and we're talking 4G, 5G today, for example, and that's from 600 megahertz to 3.8 or 4.2 gigahertz right now. Those are the frequencies being used, even if some of our antennas are already over spec to go up to 6 gigs, because we anticipate some applications in those frequencies already. But if we consider those frequencies, 600 to 3.8, 600 megahertz to 3.8, you need to ensure that that gain it's going to be balance with the radiation pattern. And what this means is that if you increase the gain a lot, your radiation pattern, think about it like a flashlight. If you put your gain up like in the 12 dBi, your aperture will be very sharp. So you have a flashlight condensing all its light in a spot. Now, if you take this to a vessel, and the vessel has all those pitch and yaw and roll movements out in the sea, this will make it that your connection will be very unstable because you'll be overshooting or undershooting the masts which are inland. So there's quite a lot to be said regarding gain because gain is, for one thing, is not only that number that you see on top of the datasheet, because the gain of a given antenna varies depending on the direction and on the frequency of that antenna. And then this balance between gain and the radiation pattern, making sure that you're capable of receiving the signal from all directions, being truly omnidirectional. That's something that we do really well, but also the vertical aperture when we're talking about maritime spec antennas. So yeah, I think there's quite a lot to be accounted for. Let's just not focus on gain because that's a very, if we understand what we're saying, we need to look for frequency gain and radiation pattern and the balance across all of these during the frequencies that for all the frequencies that our antenna is catering for.
I think people sometimes forget that the sea is not flat, isn't it?
And yeah,
it really can make a difference when you're on where the waves are going. So yeah, that really does make sense. The materials you've already really talked about, I think.
in terms of mechanical things, I think one thing is or mechanical aspects of our antennas. One thing is, of course, the plastics and what's the enclosure going to be made of. And you see that we have two types of plastics that we use in our maritime antennas. The first is UV stabilized ASA plastics. This is what you can find on our 400 series, for example, the 493, the 414, the 402. They're highly reliable for sea environments, UV resistant, saltware protected, so they're salt protected as well. And in our higher end on the Narwhal series, the 900 series, we have fiberglass, and these fiberglass applications in the maritime world are immense, and everyone can understand the importance and how well tested and how trustful fiberglass is. And then we have, of course, some of the IP68 and IP69K, those are foam filled, and that helps with water ingress protection. And they are IK10 rating, and this helps with impact, be it impact from whatever, birds, water jets, just the wind and the vibration that's being created as the vessel sails, right? All the metallic elements need to be 316 stainless steel. because that's the bare minimum you can put on a vessel. And then the final the final element really is the manufacturing and the quality standards that we have in place and the quality barriers that we have in place to ensure that the antennas have the quality to be great as maritime. But yeah, that's just a few bits that account for making good mechanical good antennas on the mechanical end for the maritime applications.
So with regards to materials, do you do them in different colours or can people paint them? I'm just mindful that if somebody's bought a $15 million boat or ship, they're gonna want it to match. So if the ship is black, I remember the Barcelona one. We were in Barcelona and I saw a picture that you had all shared, and it matched. So did you make it that way or did the customer paint it?
No, the customer did it. There are quite a number of very knowledgeable people in this industry, so of course, and they are used to that kind of requirement. You spend a lot of money in your vessel, and then you need to make, especially when you're talking about leisure vessels, merchant vessels, and ferry boats. They don't care so much about this, but leisure vessels, yachts, mega yachts, super yachts, they do care about it, and they can paint them. And these system integrators and these installers, they're used to this kind of requests, and they're already used to antennas as well, which is a big and beautiful thing for us in terms of market, which is the maritime market understands antennas and knows antennas because they've been dealing with VHF, UHF, satellite antennas for a long time. So they know they can paint them as long as they don't have any metallic elements in the paint, right?
Yeah.
So to avoid any kind of change to the radiation pattern or blockage from the signal to go in or out. So that's the one concern. But other than that, people meaning companies are doing it themselves.
With regards to the WaveHunter, we've sold those and we've been talking to people about them, and they never take the pedestal. Why is that?
I think John can answer that one, but goes in line with what I just said. Yeah.
No, yeah, the pedestal, it's something that you customize because some boats need a 30 centimeter pedestal, others need 1 meter, 1.5 meters, 2 meters. So it's mainly done in a shipyard.
Yeah.
Because they what you just said, they are experienced with TVRO, they are with satellite domes, they know that, and they are using those pedestals as an example. And yeah, you can modify them any way you like, and it's also for shipping the goods. It's cheaper to do it locally than let's say build it in South Africa and then ship them to Europe, for example.
Yeah. Well, that's what happened to the one. Well, we did two, didn't we, earlier in the year, and they didn't take the pedestals. And I thought that was quite interesting. How at the time when I inquired about the pricing and so on, I was told they don't normally take the pedestals. So it was quite interesting.
I think I'm in the maritime industry for over 17 years now, mainly satellite communications. And I have talked to CTEL, Copem, Intellian, and they all sell the antennas without a pedestal.
Right. Okay. Are there any other considerations that they should take into thought when they're buying these sorts of antennas with regards, mounting them and so on?
No, not really. The considerations. I have had a brief look at your questions. Considerations is really about pulling cables that determines what antenna solution you choose. If you, for example, if you have a dual 5G router and a dual 5G router has 8 antenna connections. If you just want to use stick antennas, then you need to pull 8 LMR 400 cables, for example, and that's a big wire, and that's why you see now a big shift towards all-in-one antenna solutions where you can house the router inside the antenna like the Ripple and the WaveHunter, so that you only need to pull an Ethernet cable or multiple Ethernet cables and a power cable. Or even if it's powered over Ethernet, you just need to run one small cable instead of 8 or maybe 16 thick LMR 400 cables.
Have you seen a big interest in these types of antennas?
Yeah. We've seen that. Yeah.
Yeah.
For example, a ripple antenna. Normally, if you want to install, let's take for example a dual 5G router. So 8 antennas. If you need to pull cables for 8 antennas, and you need to mount 8 antennas and install the router, it normally takes 2 days. The advantage of, let's say, a Ripple 8 with 8 antennas inside, you can do the pre-configuration of the router at your office
Yeah.
without any wind and rain and whatever. You can open it, you can mount it, and the only thing that you need to do on a vessel is put it on a pedestal and pull the Ethernet cable. And if it's already done, you just need to connect it, close it, and that's it. So the installation time will go from 2 days to 2.5 hours.
Yeah.
And that's a big advantage in shipping.
Is there what would be the main reason someone would go for a WaveHunter over a Ripple? What's this significant difference? Because there's a significant price difference. So what would be the biggest difference as to why you'd want a WaveHunter instead of a Ripple?
I think the Ripple is a lighter product, like John was saying. So easy, it's a one-man job. It can be installed by a single person. And then there's of course the difference in terms of design of the antennas and even the number of antenna elements that you have inside. So the WaveHunter is a multi-directional antenna. So indeed, you can have the 360 degrees coverage like you need to, right? Because you don't know what's the position of the vessel when relative to the coastline where the masts will be. But to ensure that with a WaveHunter, you need to install at least 4 5G or 4G Cat 20 or Cat 12 routers to ensure that each router will be responsible for 90 degrees or 60 degrees. So let's take it, 4 modems will be, modem 1 would cater for sector A, which is 90 degrees, and then modem 2, sector B, other 90 degrees, and so on and so forth until you get the 360 degrees. This will necessarily mean that there will be moments in time where there's one of those routers that's not picking up any signal. Say you're selling from the UK to Ireland, you leave the UK, and then you have the UK on your back and Ireland in front of you, right? There's a moment in time where only the antennas facing back to the shore of England or Wales will pick up any signal, and then there will be a moment in time where only the antennas facing forward to Ireland will pick up any signal, right? So this is something to have in mind. With a Ripple, this doesn't happen, right? It's all of them are omnidirectional antennas, even if we still have the dual polarization, which is a massive differentiator from standard stick antennas like the Narwhal series, the 900 and the 400 series, and most of the antennas in the market. So this dual polarization will ensure twice the throughput, but directional antennas allow us to have higher gain while keeping a very good aperture. So that balance that I was talking about is ensured nicely on a directional antenna. Not only that, because directional antennas only hear and talk to a given direction, they're not so prone, they don't bring all the interference that you may be hearing 360 degrees with an omnidirectional antenna. So in terms of it really is, it's hard to say when to use one or when to use the other. It's a case by case. It's what kind of results, what kind of needs do you have, right? So what kind of requirements? The WaveHunter, in a way, will bring you further away from shore, and you'll keep connected further away. But at the moment in time, it's not probably you're not going to connect the 4 or the 6 routers. It's only 1 or 2. Is that enough for you, right? Or would you rather sacrifice reach and ensure that you have more routers connected? While you're connected, you want to have the 4 routers and the 4 SIM cards connected, and then you can play around with SIM cards as well. So it's not a easy equation. You need to understand the 2 products. The easy thing is, like, if you don't really know what you're doing, the Ripple is your way to go because it's cheaper, it's omnidirectional, the installation manual is very simple to follow. You plug and play, it's okay. If you really want to provide a tailor-made solution to your customer and you really know his needs, you can then equate and consider the WaveHunter. If the WaveHunter wasn't if it wasn't the product it is, we wouldn't have a certification program for it. As you know, as Solwise is a certified WaveHunter distributor, you and your team had to go through training on understanding the product, on knowing how to install, or advise on your system integrators on how to install it. So it has its tricks. It does indeed for some cases outperform the Ripple and bring better results. So but it is a use case dependent kind of thing.
Well, it's like all these things, whether you're buying a £60 antenna or a £15,000 antenna, it's getting the right one for the job, isn't it? That's what we always tell people on the phone. And because they'll say to us, oh, I want the one with the highest gain, the biggest one, the most expensive one. But that's not always the answer, is it? It's about having the right antenna for the right job and the job that you're doing. So yeah, that would make sense. And I suppose that'll be the same when you're looking at things like the difference between the Narwhals and the 400s. It's just about having the right one for your vessel, because you couldn't put a Narwhal, for instance, probably on a barge or a narrowboat, because it would be probably overkill. So something like the 400s or the 291 or something like that would be a much better solution. That makes sense. So John, recently you've written an article about Starlink and how that fits in with all of these types of things. If you could give us a bit more information about what you discussed in that article and your thoughts on that. What we will do is we'll share a link to the article in the notes for the podcast as well. But I'd be interested to know where you think Starlink fits in. Do you think it's going to take over from what you're doing? Is it a nice complement to each other? It's the new kid on the block, so we need to know what you think.
Yeah, well, we would like to call it a disruptor, and it's always from time to time. It's always nice to have a disruptor in your industry, because it will shaken the companies that are working for many years the same way. They will be awakened by the new kid on the block, and Starlink has certainly done that. In the first couple of months of this year, we've seen a rapid growth of Starlink, and people not interested in 4G, 5G anymore. But just in May, June time, we saw that coming back again, because they understood, hey, Starlink and 4G, 5G can be in addition to each other. They can complement each other. You can bond. You can do a lot with the two systems separately, but also together if possible. What we see, and that's why we also wrote the article a little bit to get people to understand that, yeah, it's not just Starlink or just 4G, 5G. You can easily combine them. And what we see is that, for example, in super yachts or mega yachts or whatever yacht it is, that when the owner is on board, he will get the Starlink dish for his convenience and his data needs, and the crew can go on 4G, 5G. And when the owner is leaving again, the whole vessel can benefit from Starlink and from 4G, 5G. And that's combinations that you see, but also in certain areas in Europe, Starlink is a pay-as-you-use service. So you need to buy a certain amount of data on a monthly basis. It's a month-to-month contract. It's 1 terabyte, 5 terabyte, or 50 gigabyte. And in some regions in Europe, it's still cheaper to have 4G, 5G. And if you have a local vessel there, yeah, why don't go for 4G, 5G?
Well, if it works, and then, it's one of those things, if it ain't broke, it don't fix it, isn't it, really? So,
yeah. No, indeed.
Yeah.
So, yeah, no.
Starlink is quite expensive at the moment as well. So I don't know if that's the same across Europe, is it?
Yeah, expensive. Define expensive, because it's the market that you are in. If we are talking about satellite connectivity, for example, if you have a satellite connectivity 1 megabyte speed, that's 512 down, 512 up, or 256 and 768. you pay anywhere between $1,000 and $1,500 per month.
Yeah.
That's unlimited for a very low speed. With Starlink, let's say for $1,000 per month, you will get 1 terabyte of data, but against 200 megabytes of speed. So it's all, how are you going to use it? What are you using it for? We have vessels that are sailing 85% of their voyage in Europe under 40 5G coverage, and the crew is doing 700 gigabytes per month. For them, it's still cheaper to use 4G, 5G than commit to a 1 terabyte Starlink commitment.
Yeah.
I suppose if you've got your £50 million super yacht, it probably doesn't make a right lot of difference, does it?
No.
No, but it in a way it does as well, Louise, because a lot of times these vessels are chartered and it's a business behind that vessel, right? So what we see is exactly what John is saying. So let's say critical communication, and they allocate the bandwidth from Starlink up to 1 tera, so €1 per gig, and they allocate it there. And they know this is ubiquitous. They can get connectivity almost everywhere, and it's working from what we hear quite well across Europe and across the globe as well. But if you look at 4G and 5G packages, and they are coming under the €1 per gig, and if you want to provide your employees, so the crew who's working, and the crew is living in that vessel, so they need to phone their families and friends, watch Netflix. You need to use internet like you and me use at our own houses, right? So then it's very, very quickly you go over these 1 terabyte. And then the cost with Starlink goes from €1 to €2.5, more or less, give or take, right? And then if you can still keep that under €1 for 4G, 5G, which you do, it's, from a business perspective, running the owner of the multi-million pound vessel didn't become a billionaire or a millionaire by spending all his money, right? He is wisely spending it. So they go for it. And that's what we see and what the industry calls hybrid connectivity. So use the two means of communication, use them wisely, understand your business needs, and then adapt accordingly. But as John was saying, indeed, there's no one or the other. You definitely, and that's why as well, we as an organization, it was a massive disruptor for satellite communications. For us on the satellite, on the 4G, 5G end of things, it was positive disruption. So it got all the businesses to reassess what they have been doing for 15, 10, 5, for the last 15, 10, 5 years, right? Now they need to go back to the whiteboard and say, okay, how do we connect everyone inside of the vessel? What options are there? And because they're now reassessing what options, they already going to make a fortune. They will save a fortune from their existing satellite contracts going into these ones. But while they're at it, what else can we do? How else can we optimize this? So for our antennas, it has been a good moment in time as well, because people are looking at it and reassessing their options. So it's quite good.
Yeah, I suppose really there's, because it's got people talking as well, hasn't it? So even people who had never considered it before are thinking, oh, well, if we could go for Starlink and we use 4G as a backup, or we could go for 4G and use the Starlink as a backup. It's like we said earlier, it's the right tool for the job, and it might be that using both works for everyone. And as John said about if the main person is on his yacht and he's using the Starlink and the staff can use that, having multiple networks as well, I think is really useful for everybody. So lastly, I just wanted to let you know, we've sold a few WaveHunters now, and one customer came back to me and his comment to me was, it works splendid. So I think that's probably the best thing we could expect, isn't it, really? So
no, absolutely.
We can finish it there, because I think that's with a happy customer is a nice place to finish it.
Definitely. Definitely.
Thank you, guys. Thanks for joining us. It's been really useful. Thank you very much.
Thank you for having us.
Thank you.
thank you for either watching or listening to today's podcast. If you've got any ideas, pop us an email over to sales@solwise.co.uk, and we will see you next time.